Okay, what do you think about that? The first one is specifically about temperature, where the second one isn't. Keep going.
You kind of have parameters with the first one as well, because like temperature can only be so cold and so hot.
Okay.
I guess. Going out on a limb, I think they're functionally identical.
He says they're functionally identical. Jacob, right?
Yes.
And Lauren, is that right?
Well, I was going to say, if we defined x as temperature, there's nothing stopping us from x being, temperature. But yeah, I kind of agree with Jacob. They're the same function. They just have different inputs.
Does GC think to itself, oh, that first one, that you're talking about temperature, and the second one, no, you're not. Is that what it thinks? So it has no idea what quantities we're modeling, right? It has no idea what quantities we're modeling. Are they the same statement? Exactly the same statement, except for, obviously, we draw a t and x differently, but beyond that, are they the same definition of a function? Exactly the same, okay? So when you define a function in GC, if you use x, it's not thinking about x as the x-axis. Now, when you define a function, it just is a symbol, just like capital T is a symbol. It's the argument of the function, right? The argument of the function. So these two are exactly the same. What about... Oh, I had a really good idea, but now I forgot it. So let's go back to this first one. So what if I type this in? How does GC interpret that? Yes?
The line equals prompts it to want to graph.
Okay, so it's going to graph something. What is it going to graph? Yes?
It's going to plug the t value, which is probably the 1, to the previous function, get a constant.
Okay.
Graph y equals that constant.
So the graph will look like
Horizontal.
all lines are straight.
Horizontal.
Horizontal line, right? He's saying that will graph a horizontal line. Agree? Don't do it. So if you have GC open, which is okay, don't do it. So we want to think about it. Don't just look at what happens. So are we in agreement? It's going to graph a horizontal line. And that horizontal line will be at the y values such that t equals 1, because we haven't defined it otherwise. It's by default. And then whatever the attendance would be at a 1 degree temperature, or whatever this function gives.
One is a default, so it's easier to troubleshoot. So if you get a weird value, it's easy to trace back.
No, I don't think specifically for that reason, but it's just the natural choice, I think. The natural choice would be to let variables be 1 if you haven't defined them. Okay, so let's just do one more situation here. How about if I did this? What's this going to do? Okay.
It's going to graph a function because you're letting GC know that t is a function of x, or t is x, so it's not going to plug in 1 anymore.
So now we're going to get the curve.
Yeah.
Okay? Kendall?
Since the input x doesn't match the input in the function, it'll still give you the horizontal line, I think. Actually, hold on, I take that back. Yeah, I think the input x horizontal line. The input doesn't match the function, so if you were to do like a of 1, your output would still be just that, the same thing that we just had, because there's nothing to input.
You disagree?
No, I think it'll input x into t.
It'll input x into
So it'll basically replace t with x and therefore graph.
graph the curve.
Yeah.
Some people are saying graph the curves, horizontal line. Who hasn't? Go ahead.
I think it'll be a conflict because your argument and your rule setup or definition aren't matching. So I think it'll define just the x as one and the t as one, but it won't link the function to the y equals a of t.
You have to think about it. Here we go.
Because right now the t is just 1. So maybe give you pi, like if it had a of x and replaced t's with pi's, the x shouldn't replace the pi. Because right now t is just a constant.
Okay.
We haven't defined t.
So
We shouldn't graph the curve.
how is it looking at? How is it taking x in this? Is it taking it as the x-axis, all values x?
Just the,
What about capital T? What is so? What? Okay.
So the rule doesn't have.
So maybe let's just forget about the second line and just say, what is this function like? The way we defined it. What is this function like? Come on. Lauren, sorry.
Well, no matter what you input as x, like if you were to input 5, 10, 15, you're always just going to get negative 0.01 t squared, blah, 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 because your input x is not found anywhere in the rule of the function.
Okay.
So for any input, no matter what number it is, you're still just going to get the rule.
So maybe this is the better question. What's that going to do? What's that going to do? Shayna, what do you think?
I think that no matter what you put in the second line, it's not going to graph anything because it's going to look for inputs. But since their inputs aren't matching the arguments, it's not going to plug anything in.
So it's going to be like an error message, kind of? Error message. Vern.
Well, GC thinks that capital T is 1.
Okay.
So that first line A of x equals all of that is just some value.
Just some
T
value,
equals
okay.
1. So the second line will graph y equals whatever that value.
so it should be an
Okay, she nailed it. So she nailed it. And lots of you had good responses too. But yeah, exactly. The way this is just defining a constant function. Whatever you get when t equals 1 is some value, and then it's defining a of x equals that value. So when I do y equals a of x, it's going to graph the same horizontal line, right? Because it's just saying t is 1, so all we did was do a of x equals a constant. This is a constant function, so when we graph it for all values of x, we still get the same constant function. Yeah?
If you were to change the second command line back to a of t,
Okay.
would it still just graph that?
All right, so what would that do? So let's go to the second line, and it does a of t.
Well, your t is still 1.
It's the same thing as t.
So how does it, so yeah,
So you're saying that a of x is a constant function,
right?
So you're saying for any input of a, you're going to get whatever that constant value is. So you're saying the input here is t.
So we're gonna, which is what we're gonna input? 1. It's gonna input 1, and it's gonna go up here, and it's gonna say, okay, what is the value of this function at 1? And what is that? That same constant. So it's going to do this by picking off a particular correspondence point. And then it's going to graph the same line because it's going to just, so it's not graphing this function, it's graphing a horizontal line at the value of this function when t is 1. So it's going to be the same horizontal line, but just kind of in a different way. Rather than really like graphing this as a constant function, it's pulling off one correspondence point, the point 1, comma, this constant, and then graphing that everywhere. So it gets the same result, but a little bit different way to think of it. Okay, so let's try something else. We'll go back to capital T. Somebody new? Tell me your name again. Camry, what do you think? So I've got a of t equals this expression of capital T. And I'm going to graph y equals a of pi.
I think it's gonna substitute pi for every t in the original function, and
Okay.
it's just gonna be the same straight line but a different value.
So it's going to be a horizontal line, but a different value, the value of a of pi. Was that a different place? Okay, I don't remember. Is that higher up now?
Yes.
Okay. How do we get the actual curve? So I want to graph the function. So that's what I want to do. So I want to graph the function. But I don't have x's up here. Right, so this is, so is capital T 1 here anywhere? Left or right side? Is capital T thinking it's 1?
No.
No, this is a function definition, so it's just using T as a placeholder, not as a variable. So it's looking at capital T is different than a variable here because we are defining a function. It's just holding the place of the independent variable. And so now when I do this, there's no ones involved up here. It's truly defined a function, and now we're gonna graph it. And we want to graph it from what to what? Anyone remember?
0 to 10.
So there was an issue with my animation and the packet being something different. And so if something ever that comes up like that, then just ask yourself, okay, so I want to make this the most effective and efficient animation that I can, whether it's for myself or for a teaching class. What would make more sense, right? What would make more sense? And then as long as you can justify your reasoning for your choice, that's good, all right? So there's, that's fine. So was it on the animation, did I show up to 120?
Yeah.
Okay, so I'll just do that. Okay, and so then there was this issue at the end. So let's see if we can. So we want. How do we get the roving point? The point is control 2, and I want the point that's. So I want my x value to be n and a of n. So that's somewhere to start, and then I wanted. Was it a? And you guys learned how to change the settings on the parameters. So we want to go from 0 to 110. 22 steps. So it goes by fives. 2 steps. No. 22. Okay. And then I think we wanted to have a show, starting at that point, we wanted to show a change of, was it 10 or 5? 10. So if I want to show a change of 10 in temperature, starting at that point, what kind of thing is that? So I want to give GC a mathematical statement that's a set of points. So how do I show the set of points showing a change of temperature of 10, starting right there, across that way? So we've done this before. Tell me your name and the visor right here. Yeah, wearing the visor, yeah. Tell me your name. What is it?
Bianca.
Bianca, sorry. So did you remember how to do this?
I'm sorry, what was the question?
The question was, I want to show the change of temperature of 10 starting at our roving point, n comma a of n.
Oh, the n plus 10?
So do I just type in n plus 10?
So y equals a, n, and then n is less than x, which is less than n plus 10.
Okay, we don't want that to be green. Okay, how'd she do? Okay, and then then I want to show the corresponding change in attendance for that change in temperature. And so without looking at what you did, can you remember what it was? Tell me your name on the far end of that table. Tell me your name again, yeah?
Okay, Angela.
Angela.
So what I did was x equals n plus 10.
Okay.
And then I got it from a of n is less than or equal to y is less than or equal to a of n.
We have n less than or equal to, so we want all, yep. And then what's the last point?
A of n plus 10.
Sounds promising. Let's make that one blue. Since we already used red, let's make purple. How'd she do? Okay, so then there was this issue with everyone clear on that much. So this is just mathematics, right? So this is not telling GC to draw a calculus triangle with changes, right? It's just giving GC the mathematics. And look, using function notation, right? So function notation, just the way that we talked about it last week, and and that's kind of a huge key to this course. We really want to develop a function mentality in this course, that we can use function notation to represent values that change, or values that we don't necessarily need to compute and do, calculate, and we can just use it in expressions to represent whatever it is we're trying to do. So here's a great example of that. So what is happening? So rather than just tell me the answer here, we lose our change in attendance. Tell me about so does someone want to share the journey that you had from, I don't get this, why is that gone, to making progress? So tell me your name. Ron?
Ron.
Okay, so yeah, tell me about your journey, your struggle, how you got from not understanding to getting it.
It took a long time of thinking about it, but I realized when you're the a of n less than y less than a of n plus 10 is telling it to do it from the point on our horizontal line up to the graph.
Okay, so
and then once we get past that certain point, from that point up, it doesn't ever hit the graph, so it's giving me errors. So
okay.
Once I realized that's what I was trying to do, I realized I could switch it to
okay.
From the graph up to that point.
Somebody else, what was your, okay, good. Your journey and figure this out. Is it Jose?
Yeah.
Yeah.
Similarly, I realized working through the worksheet that there was that point, I think it's 73 or something, that it starts to turn down. So I understood that, that point, that point has something to do with it, the point where the curve reaches the tip and then starts going down.
Okay.
And so similarly, and graphing calculator actually gives you the message that the domain doesn't fit or something. So so I knew I was looking at at one of the domains, but it took me a while to figure out to kind of visualize which one was which. But yeah, then I just figured out that it was just because it says it's between the two things, and past that point there is nothing between.
Okay. Joey, did you want to chime in?
I was going to say that I figured to switch. I switched the parameters from, instead of the a of n to a of n plus 10, I did a of n plus 10 to a of n. And I saw that the line was going downwards on the left side and doesn't do anything on the right side. So I realized that same after 73, you have to.
Okay, so let's okay. Right.
So I realized that for values of n greater than or equal to 73, also you have it where a of n plus 10 is actually less than a of n. So
that's okay. That's the key right there. That's the key. So how does a of n plus 10 compare to a of n now when the function is decreasing? So what is this statement actually saying? This statement is saying what? I want all y values that are greater than a of n. Where is that right now? Where's greater? All y values greater than a of n. No, all y values greater than a of n. What y values are those? The way I've set n, so I've set n to be this x value right here. So all values of a of n greater than y. What are those points?
Those are the values above the blue dot.
She said those are the values above the blue dot. Agree? Some of you were doing some kind of motions that were like horizontal. Is this a horizontal issue or a vertical issue? So she said it's all values of y, everything above the blue dot. Morgan, what do you think?
Well, I was going to say that it is a vertical line, but really, I mean, if you're just talking about all values of y that are greater than a of n,
Yep.
you have to follow along the curve, and the curve goes to the right at that point. So like,
But I'm sorry, I chose a particular n here, right? So I chose n, and so I've got my a of n is the y value of this point. So all y values greater than or equal to a of n
At a lower end value.
So I'm not talking about the function. What I'm talking about is this set of points. If I were just to, I'm going to, in a second, I'm just going to put this statement into GC. What is it going to give me?
Just that statement.
Give you a line emanating from that purple line going straight up, right?
He said a line from the what?
Emanating from the blue point.
From the blue point, straight up. They'll give me a line going straight up from the blue point. Okay, talk at your table. What's this going to do? I'm going to put in y is greater than or equal to a of n as a new command line, as its own command line. What is it going to do?
You just have a straight line that would be values from that blue line.
Specific values, you want everything greater than it.
So what do you guys think?
It'll make a line, horizontal line, and then it'll shape everything above that.
Is that what you say? Yeah.
It'll do it at the blue dot.
So a of n, right? So n is currently 95. So I think last of you are getting it. What do you guys think? What they said? Is it going to be a line? What's it going to be? What's your favorite color? I got green. Is that okay? Let's see some green. Is that what you guys said? Okay, and then if I were to do y is less than or equal to a of n plus 10, what's going to happen there? How about some turquoise? Plus 10, right?
Oh,
So it'll be like, yeah, it'll be
Ready to go swimming? So, do you see what's going on? So what does this statement said? This statement says what? All points that are in between the two colors.
not in between the two.
That's what that says. All the points that are in between the two colors. No. What does that say?
They're greater,
All the points that are
greater,
in the green
no,
and in the blue. And what points are those? None, right? There's no points in the green, and also there's no y values that are in the green and also in the blue. That's why it says undefined. It's not going to plot any, not going to graph any points because there are no points that are both in the green and in the blue. So what do we really want? So when we want to sketch this little line right there,
You hit play right now, will it move the colors?
yeah, it will.
Yeah.
I want to see that. But the problem is we've got n too much here.
This is how I see all that.
Come on. Why do we have a third color? Oh, so if you wanted to start over instead of going back, hold down Option while you hit play. Mac, I don't know about a PC. So if you have a Mac, you just hold down the Option button while you hit play. And that's when it gets to the highest value of n, it'll go back to the lowest value of n.
That's where our assignment might be incorrect if we go back and
No.
forth. But that's just a default.
Yeah, that's not part of your command lines. That's part of how you just activate the slider. So, do you understand what's happening here? Why is there a third color? Sing.
Either overlap or the white lines like
And why would there be overlap sometimes?
because the teams are positive.
Can I pause it? Is that what you're asking?
Yeah. So it's like the green line is anything above the dot.
Yeah.
Right. The blue line is everything from whatever the new points are below.
Right.
So they have overlap.
So for those y values is what you're graphing x of n plus 10. So those y values in the overlap region is what you're graphing x of n plus 10. And you get that vertical line because it's x equals for those y values. We come out here. And now there are no y values that are both greater than a sub n and less than or equal to a sub n plus 10. But we know, so what y values are those? Ryan, what should I type in? If I want to get the, over here, I want to finish the triangle.
Oh, almost the exact same command line. X equals n plus 10
Right?
for y, or for a of n plus 10 less than or equal to y, less than or equal to a of n.
So now, yeah, now we want all the y values above a of n plus 10 and below a of n. Okay. Any questions about the assignment? Just see it working here? Not yellow. There we go. So now we got it. Turn these off. So can we get that, the change in attendance in one command line? Is there a way so that in one command line, it will show that change in attendance for all values of temperature? So think about it. So let's just have everyone think about it. Not right now. So that's just throwing that out there. We're not going to work on it now. Maybe that's just part of our mini assignment for Thursday. So is there one command line? Is there some other mathematical construct we can use or other way to do this? So in one command line, rather than having it be two command lines where one is always undefined and the other is defined. Okay. So if you have an idea, just don't tell the person next to you, right? So if you have an idea, just don't tell. Let's let everyone go through that problem-solving process. And if then someone wants help, telling them the answer is never help, right? This is not good tutoring. Telling someone the answer is never good help. You always want to find out where the person is at, listen to their thinking on the situation, and then try to ask a question to help them move in the right direction. But just sitting down and telling someone, you have a eureka, and it's really tempting to be like, I got it. I want to share it. But for their sake, if they want to work through that problem-solving process, we want to hold back. We want to hold back and, give good help rather than just a free answer. Okay. All right. So let's we'll just do a little practice activity, real simple, or should be simple if we're catching on. This is maybe just a way to see how you're doing, if you're retaining what you need to retain. Okay, so pull up GC, get a blank window. So one thing I want to show you is that you can insert your own text in between command lines by doing Command T. So if you do Command T, it just opens up a place for you just to put text. And you can change the font, you can change the size, you can do bold, italics, so it's something of a word processor, a very primitive word processor. You can do that. How in PC? Is it Control T? Control T on PC, Command T on, and this is really helpful when you have very involved files that have lots of mathematics and lots of lines. Put text to organize your file. But what I want to show you is what I've done here is I've just used text, and you can highlight text, and then you can grab it and throw it on there just for visual. And that's what I've done. You don't have to do this. I'm just showing you. So you don't take the time to do this. But this is how I've created like some larger values on the axes, so you can see a little bit easier. But that's how I've done that. It's just by highlighting and grabbing text, and you can just drag it, and then I can come back here, and I can drag it around, move it, and then.
Change the window. Do the numbers stay there though?
Yeah, so that it gets messed up. Watch. If I zoom in, it doesn't stay in the same place in the coordinate plane. So it would only be for a particular view that it would work. And if I zoom out, it just gets all messed up. Okay. All right. So and then if you want to get rid of it, you just drag it. And everyone, listen. Ready? Did you hear that? I love that. Okay. All right. Okay. So yeah.
What about the box lines?
Okay, so that was something that I put in with mathematics with command lines,
Okay.
and you can too. So let's do that. So you can put in. No, it'll take too long. So I want to show you how you can. I wrote all those vertical lines with one command line. Okay, and I wrote all the horizontal. So I trust that you could do those vertical and horizontal grid lines one command line at a time. That should be really easy. So maybe we'll just do like 4 of those. And then I'll show you how you can do them all at once. But the first part of this activity is to plot those 3 points. Plot those 3 points. So this is just review, practice. We all should be here without having to look something up. Because all of this stuff that we're learning at the beginning of the course, you have to retain it. When these projects get difficult, you can't be unsure on how to graph a function or how to plot a point. You can't be unsure on those things. So you're going to plot those points. Everyone got it? So if you've already forgotten how to plot a point, you're off to this semester's going to go very badly. So you've got to retain everything, all these basic things. You've got to retain it. So quick, ask someone and get that taken care of. Get those points, please.
When you drag it, you push something?
No, I just highlighted and then I like double clicked. Or just the way you would like grab and drag something else in any other program. I think it's double click, right? Or is it just single? It's just single click, yeah, just drag. It's just single click, drag and drop. That's on a Mac, yeah. Does it work on a PC? Anyone got it? That might not work on a PC. Okay. So originally GC was a mathematical program that was designed in the Mac operating system, and then someone bought it and continued to improve on it. So it's still really a Mac-based program. So PC has some limitations, okay? But it still does all the most important things we need to do. Okay, got the points? Okay, so now I want you to graph that, and I want you to do this in two ways: with and without a function. So with and without defining a function. Graph this set of points that I just put up there. So with and without using a function. So maybe graph that. Start without a function. So start without defining an actual function, and then do it again by defining a function. Okay, next task is roving points. Practice roving points using the N slider. Roving points on the curve. That moves according to N as N changes. And make it so mine does not, but I want you to make it only rove on the part of the curve that you're displaying. Okay? Make the point rove only on the part of the curve that you're displaying, and that's not what mine is doing. Okay? Okay. What is the advantage to not using a function in this case? Is there an advantage, or did you discover?
Not really. It's quicker. If you recognize the shape of the graph, it's quicker to write it in. But then function notation is a lot better because you can utilize it.
So quicker to write it in.
Yeah, like y equals square root of x was faster than defining a function and then graphing y equals that function.
Yeah.
In terms of needing that sliding point, though, at least I don't think there's an easy way to define it without a function.
Okay, good. So yeah, so it only takes one command line to graph without a function, right? You can just boom, do it. It takes two command lines. You got to define the function and then use it. But now with a function notation, there's all these things we can do, like your calculus triangle, the roving points, right? So that one extra line by defining the function does a lot of work for you. Okay, so here is the next aspect to this. I'm going to turn off my axes. If you go to graph, you can turn off the light blue graph paper. You can turn off the axes in that menu. I'm going to turn off my axes. I'm going to show you that there's something else on my.
Oh, that's cool.
So this new thing that now I've revealed, these blue and red segments. What is it that they're thinking from a teacher's hat? What is it that they are showing or demonstrating? What is it that this blue and red segment are showing? Jose, got an idea?
The horizontal and vertical distance that the point is from the origin.
Okay.
The distance the point is from the origin in each direction.
And what are those distances? Somebody new. Tell me your name in the red shirt right here again. Tamisha? So what are those distances, the red and blue distances? Okay. Okay. Yeah. It's true. The numbers that change. Okay. So rather than call them distances, what are they, Morgan?
Well, the horizontal length is f of n, and then the vertical length is
Okay. Okay. So they're representing n and f of n. Okay. Tell me your name again.
Genevieve?
Genevieve. So that n and f of n are what about that point?
The n and f of n are.
What's that?
The
The coordinates, right? So it's what is this? It's showing the it's showing how those two quantities are coordinated, right? Because it's showing all the blue line shows whatever the value of the x coordinate is, and then the red is showing the corresponding value of the other quantity, the y coordinate. Okay, do it. Build the grid of light gray lines that I'm showing. If you've got nothing to do right now. Okay. Build the grid of light gray lines. And there's a light gray box. There's a light gray color choice. Okay, let me show you how to say do all those vertical lines at the same time. So all those vertical lines are of what form? All the vertical lines in my grid would be of what form? X equals?
Vertical, horizontal, vertical.
So I want the vertical grid lines. Will all be of the form? Vertical grid lines. X equals. Okay? Now, so x equals the different constants, right? So I can just put x equals a variable. Just choose any variable. And then I can do comma. A is a member of control equal. Control equal. Anybody find it for PC? Is it control equal? Control shift equal?
It's control shift E.
E?
Yeah, control shift E.
Control shift E for PC. Is that Peter? Is Peter the hero? No. Oscar. Okay, here we go. So, and then now we're going to use set notation. So we're going to do shift bracket, set notation, and all you need is the left, and it gives you both. So shift bracket gives you the braces, the set braces. And then I'm going to go, watch, I'm going to go 0, comma, 1. So I could just type in a list. 2, 3, 4, 5, 6, 7, 8, 9, 10. I could do that. That would work. But say I wanted 100 of these. So you establish the pattern. Everyone listen. You establish the pattern with the first two. So I can do 0, comma, 1, comma, so it knows it's going to increase by 1 each time. And then I'm going to do control semicolon. Control, is that PC works too? Control semicolon is, is that called ellipsis or something? And then another comma, and then the final value. So I'll put 10. And now it'll graph x equals a simultaneously for all those values of a, 0, 1, up through 10. That's handy in lots of, if you're doing the same thing over and over again. I did a bike